Alright, good afternoon everyone and welcome to UOW Malaysia KDU's Jingle Mingle 2021, brought to you by the School of Computing and Creative Media as well as its student club, Science Collective. My name is Victor and it is my pleasure to be able to be here to start off the show with everyone. For those who are not familiar with Jingle Mingle is a yearly event that showcases and celebrates the work of students within the School of Computing and Creative Media. These are the projects that have been in the works for the past year, and we are absolutely thrilled to be able to show everyone the unique games, art, and innovations that our students have worked hard on. Now, before we begin the show, Jingle Mingle will be streaming live on YouTube and for our students on Discord as well. If you are a School of Computing and Creative Media student and you're interested in experiencing the works of our students, you may do so by registering via the following link. The link will also be provided in the description below, so do check it out. Jingle Mingle will also contain TAC points for our diploma students. If you are a diploma student and you are planning to apply TAC points, please register yourselves with the following link. Don't forget to at least take 2 screenshots of the event to be submitted afterward. Alright, with that being said, let us start the event. Innovation is an integral value of our university, and to start off the event, we're happy to present a compilation of projects that our computing students have worked on.
Good morning everyone. Today I'll be presenting about my final year project, which is ovarian cancer diagnosis system using computer vision. So my name is Lupin Hyok and my student ID is 0124343 from the school SCCM. So before we start, I'm going to talk about the problems. So currently, ovarian cancer have the highest fatality rate in all gynecological cancers, such as breast cancers and so on. So secondly is that the current diagnosis system used to detect ovarian cancer is heavily dependent on the physician's ability, meaning there's no such system that is able to automate itself to detect ovarian cancer. And lastly, ultrasonic image, which is the main source of medical image used to detect ovarian cancer, contains a lot of information which is hard for human eyes to distinguish. For example, ultrasonic image is in grayscale, meaning it's in the shade of black and white, therefore making it very hard for human eyes to find the point of interest where the ovarian cancer might be. So moving on, we have the solution, so the problem solution. So firstly, we can use computer vision to study the features of ovarian cancer in the early stages so that we can detect it early on. And secondly, we can use proper pre-processing techniques as well as large amount of data in order to train the model and obtain a higher accuracy model. For the last one, we can create a computer-assisted diagnosis system in order to reduce the physician's workload. So moving on, we have the research design table. So in this table, we'll be focusing on the research question as well as the research objective. So to start off, the research question. So how does computer vision help with diagnosing ovarian cancer? And the objective here is to investigate the existing hybrid classification method and image processing techniques that is able to differentiate between different tumors. So the method that we'll be using to achieve this is through literature review, where we'll get a list of hybrid algorithms that is used in computer vision. As for the second research question, can the use of computer vision improve the accuracy of early detection for ovarian cancer? And the objective here is to design and develop ovarian diagnosis system by using hybrid classification method. So we'll be using prototyping method where we produce a prototype as well as to get the feedback from the user. So the last question is, how will the system help in treating ovarian cancer? So the research objective here is to validate the accuracy of ovarian cancer diagnosis system. So the method that we'll be using is experimental method, where we'll produce a working prototype with high accuracy. So moving on is the project significance. So the project is significant towards these 2 groups of people, which are the females as well as the doctors. So females is very straightforward and direct, because as we know, females are the one affected by this ovarian cancer. Therefore, by having the system in place, we can detect the ovarian cancer in the early stages, making it easier to be treated as well as lowering the fatality rate. As for doctors, currently doctors are the main source of detection method used to detect ovarian cancer. Therefore, by having this system, we can lift the heavy load off doctors' shoulders, as the system might be able to replace doctors as the main source of diagnosis, given that the accuracy is high enough. So moving on, we'll be talking about the project scope. So in this table, we can see we have three functions. So basic function, intermediate function, as well as advanced function. So the basic function is that the system shall be able to recognize the input images. So we can see here there's no classification going on. As for the intermediate function, the system shall be able to detect ovarian tumor through input images. So here we can see the system needs to classify the image, needs to detect the ovarian cancer. Whereas the advanced function is that the system shall be able to accurately detect any signs of ovarian tumor through input images. So the difference is that the advanced one needs to be able to detect ovarian cancer with high accuracy, as we can see in the description part. We set a bench line of 70%, so we need to get the accuracy higher than 70%. So moving on, we have the technical domain. So during literature review, we have found two main sections, which are the technical domain as well as the knowledge domain. But we'll talk about the technical domain first. So in the technical domain, we know that the techniques that we can use in computer vision includes image classification, object detection, object tracking, as well as image segmentation. As for the framework, we can use Keras, TensorFlow, CNTK, and CAF. And moving on is the object detection algorithm, which includes the RCNN, faster RCNN, and YOLO. And next is one of the most important sections for the whole system, which is the classification algorithm. We can use logistic regression, naive Bayes, k-nearest neighbors, decision tree, random forest, SVM, and CNN. As for the development platform, we can use TensorFlow, MATLAB, as well as OpenCV. So for the development language or programming language, as you guys know it, we can use Python, C++, or Java to develop the AI. So moving on, we have the knowledge domain. So firstly, we need to understand what is computer vision. So basically, in simple terms, computer vision is making the system works like a human eyes. So as you can see here, to make the system understand the world through digital images. And the system needs to be able to do these few functions, which is extract the region of interest, analyze the image, as well as to understand the image, the information extracted through the image. So for example, if the system is able to classify or detect what is in the image, such as humans, dogs, cats, and so on, it is part of computer vision function. As for deep learning is an algorithm used to discover the pattern in data, given that large enough data feeding as well as longer training times. So for the last one is ovarian cancer. So like what we mentioned before, what I mentioned in the start, so ovarian cancer is one of the highest fatality gynecological cancers in the world. So as you can see here, there's more than 75% of women only knowing that they have the ovarian cancer when it reaches the advanced stage, meaning it's practically impossible to be treated, therefore making it very fatal. So by having the system, we can detect it early on, therefore making it so much easier to treat as well as to lower the fatality rate. So moving on, we have the CNN model. So the reason why this model is displayed here is because CNN model will be the main classification model that we'll be using in the system. So you can see here there's CNN UNet and CNN classifier. This two of it is actually different, but I'll start by talking about the normal CNN classifier. So usually CNN classifier will start by looking at the smallest unit, which is the pixel, in a certain shape. So usually it's 3 by 3. So by looking at the 3 by 3 shape, it will look through the whole image. It will scan through the whole image, and by doing that, the classifier will be able to get features. So we start by getting the lower features, meaning like things like lines and dots, and after the first scanning, the first iteration, it will go through the second iteration where the input will be the features itself. So by doing that, it can get higher level features. For example, the first level of features is lines and dots. So the second level of features might be corners, rounded corners, and so on. And after doing that, it can get even higher features such as shapes, square shapes, rectangular, square, circle, and so on. So by doing that, at the end, the system is able to get very advanced features whereby it might be able to know things like eyes, ears, mouth, nose, and so on. So at the end, this by combining by the arrangement of the features, the system will be able to know what is in the image, such as humans, dogs, and cats. So that's the basic features. But there's a downsides to this classifier, the basic model, uh, which is the system is unable to know where the object is. It is able to detect the object in the system, in the image, but is unable to localize the image. Therefore, we use CNN UNet, where it uses two CNN models which are mirrored against each other. So the first part is the normal model, where it will detect the object, the point of interest in the image. So it knows that in this image there's this point of interest, but it doesn't know where it is. So by having the upwards, the inverted model in the CNN UNet, the system is able to locate the point of interest, the cancer location. Therefore, it will produce a mask. So our system, my system, is actually utilizing these two models to get the mask. Then by using the mask to put into the classifier, therefore getting the final result, the classification result. So that's it for the presentation. I think it's better to show a demonstration so that you guys can understand better. So here's the project demonstration. So now we'll start the product demonstration for our system, which is ovarian cancer classification system. So as we can see here in the first section, there's a upload file section whereby the user will be able to upload the image they want to classify. So as you can see here, the file is limited to PNG and JPEG. So because we do not want the user to upload the wrong file where the system do not accept, therefore causing a lot of problems. So let's start by browsing the files that we want to upload. So let's start with a malignant tumor. So we uploaded the file, and if you wait for a while, you can see the file details being displayed. So the file name is malignant1 PNG, and the file type is a PNG file, as well as the file size. So let's start by classifying the image. So after pressing the classify image, you can see that the system will display back the original image uploaded by the user. So this is the original image. So you can see here is uploaded image. So moving on, this image, this mask image is actually generated by our first model, which is CNN UNet, whereby it will localize the area, the point of interest, whereby the system thinks there's a ovarian cancer. So looking back at the original image, the system thinks that this particular area is very suspicious, and there might be ovarian cancer there. Therefore, it's showing the mask here. So after that, we run this mask through another classification model, whereby the system will be able to detect, the model will be able to detect whether this is a malignant tumor, normal tumor, or a benign tumor. So as we can see here, it's showing here a malignant tumor. So it shows that the system detected that this is a malignant tumor. So let us verify whether it's true. So we can see we uploaded a malignant tumor image and it's classified as malignant tumor. So let us try with another image. Let us try with the normal image. And if we wait for a while, then it shows that the details is updated. So it's a normal file, and the file type is PNG, while the file size is this. So let us classify the image. So you can see the original file is uploaded, as can be seen here. So moving on is the mask generated by the model. So the system thinks that this part is a bit suspicious. Needs to take extra cautious. So after that, we run through the classification model, whereby it shows that the user is very healthy. Therefore, we can say that the classification model is is quite accurate, and it can classify the image quite accurately. So thank you for your time. That's it for the product demonstration.
Hi everyone, so today I'm going to present my FYP project, which is having a topic of food wastage business intelligence system. My name is Simson Chen and I'm currently studying for a degree in computer science. So in this FYP, I will split into 6 sections, which is first the introduction, which will talk about the background of the project, and second will be objective, what are the goals and targets of this project, and scope, which is what is the solution to solve the issue discussed on the objective, research design table, how to get started to design this system and how to work on it to create the whole system, and summary of literature review, which is what is the studies made for this project to help to create the outcome of the project. And lastly, we have the project demo, which is the demonstration of the prototype of the whole project. So first of all, we have the introduction. This introduction is that this project is to study and research on the problem of food wastage due to inappropriate refrigerations and provide a solution. The problem statement currently is that approximately every year 1.3 billion tons of food is wasted every year, and almost 40.6% of the harvested food are wasted due to inappropriate refrigeration, and because of that this food wastage also causes the environment to release greenhouse gases that are harmful for the atmosphere. According to the chart on the left side, we can see that household and distribution are having the biggest partial of food wastage in terms of percentage, and we can see that in the industry it holds around 58% of food that is produced. So 58% and 40% of it are wasted due to inappropriate refrigeration. So how do we solve that is, I've think of an idea to create a system that can predict the losses of food wastage when the food is having inappropriate refrigeration. So this project will use an IoT sensor to capture the temperature data so that it will know what are the temperature of the cooling equipments, and it will predict the losses if the temperature is too warm and so on, to calculate the cumulative loss. Besides that, it having a real-time temperature calculator, so it calculates the real-time cumulative loss, as well as the user can also calculate the cumulative loss using historical data. So first of all, the scope is split into three parts, which is the basic, intermediate, and advanced. In basic level, the device should be able to capture the temperature of the cooling equipment. That means that the temperature sensor device should be able to detect what are the temperature that are having in the equipment. Then in intermediate, the device shall be able to capture and store the temperature into a database, and if the temperature is too warm, it should be able to alert the user. And in advanced, once the temperature is stored, the machine learning model will be able to estimate the loss using the given data set. So this will be the machine learning part, that it will predict all the necessary data to show the user what are the estimated loss if they don't keep their food in optimum temperature. Next, we have research design table. In research design table, we split into 3 questions. First is how temperature monitoring dashboard system can be used on cooling equipment. So the objective is to investigate the use of temperature monitoring dashboard, and in this question we will use literature review and study of existing system to find out how can we apply IoT in business intelligence, and also list the possible feature that current system have and improvise it. The second question will be, what is the best mechanism to prevent food wastage? This is why we need to design and develop a temperature monitoring dashboard system, and we will use survey to see whether this is helpful for people around the industry, and to produce a prototype so that people can actually know what is their food condition and what is the estimated loss that they are currently facing. The third one will be, what can the accuracy of the temperature monitoring dashboard system able to reduce food wastage? This to validate the accuracy of using temperature monitoring dashboard system, and this method is using experimental, and the outcome should be to validate the effectiveness of the working prototype. So in this stage, we are supposed to have a high model accuracy with a stable model to actually perform this action to do the machine learning. Next, in our literature review, we actually reviewed that this temperature probe is actually a IoT sensor that's helped to detect the temperature, and we are using decision tree classifier, which is a machine learning model that uses induction of decision tree to predict the data, which is when one of the data go in, it will predict they will split into different branches, and it will predict through many conditions. Next, we are using Streamlit and Lumen. So Streamlit is an open source Python framework. It's used to build web applications for any Python related stuff such as machine learning and data science. So this helps to make showing of graphical illustration, graphical user interface easier. And Lumen will be used to creating our API for the temperature sensor to send and save in all the data. In conclusion, the model created is able to predict the estimate loss at the accuracy of 85.77%, which is higher than 80%, which is considered as quite accurate model. And the R-square difference of the actual data and the testing data is around 1.5%, means the difference in data is very low, means the model is very stable, and it's able to display the real-time data given. So once your temperature sensor device is turned on already, it will keep on sending data and predict the data on real time. And lastly, it will alert the user if the temperature of the equipment is too high, so that the user can take immediate action to see what they can do to actually bring the temperature down for the cooling equipment. That's all for my presentation part, and the last part I will show you the demo of my product. Hi, now I will do a prototype demonstration of my FYP project. So first of all, I have my web server started up. This web server is responsible to save in the data and collect data from the temperature sensor and save it into the database. So as you can see now, my database is created here, and I have my ESP8266 motherboard device connected to a temperature sensor, and it's run by a USB power source. So if now I refresh the database, we can see that the new temperature is actually coming in, so 30.94, and I refresh, it will run a new 30.75. Okay, the next one will be I have run my Streamlit project, then it will display this UI for the user. And the first thing, I will show the current temperature of the device, because of I doesn't really have cool equipment to simulate, so I minus 25 degree from the actual degree Celsius. So that is the basic room temperature. And as you can see, the chart here is actually keep on moving with the new generated temperature, and this is the maximum temperature that the equipment should be. So if I pull up the temperature up to this point, so let's say I burn the temperature sensor with fire right now, we can see that the temperature will be rise up to a certain point, so it's slowly rising. Let's burn a little bit more. Okay, so we can see the temperature actually rises when the sensor got heated. So once the sensor got heated, the chart will show that the user actually generating estimated loss on below. So this will let the user know that, and we also alert them to say that your temperature equipment is getting warmer. Please check on the equipment so they can take further action immediately. After that, they can track the real-time estimated loss based on this chart, and they can also check on their data on historical data, so that they can check this. All these are linked to the database, and they can check it as and when they want to see what is the predicted loss they are currently facing. So this shows some of the chart data, and also they can see what are the cumulative loss they are currently facing. So this will show that in this period of time, 2nd August to 7th of August, they are actually losing about $140. Secondly, in the means of data science, I have also do a correlation heat map to see what are the correlated values, independent variables, to better help me to choose which are the best variable to use to train the data. After picking the data to train, I split into 5 models to train with different independent variables to see which are the highest accuracy score and also have the lowest R-squared value. So as we can see that the accuracy score is quite high. 5 of the model get more than 85%, and I also included this in the report. And then real time, this will show what is the predicted value and the actual value by training the model, and we can actually explain it by using the line model to say which data are highly correlated to each other. And besides that, it will also generate a stats model chart to get more statistical reference on R-square value and others to show that this model is actually stable. Yep, that's all for my presentation demo. Thank you for watching.
Hello, good day to everyone who is watching this presentation. I am Kadiravan from final year student of UOW KDU Malaysia. Would like to present my final year project. So the title of my project is Food Review Accredited Application, and this project has been supervised by Mr. Pua. Okay, let's begin. As research have been done prior to my final year project, there are a lot of information was able to gather and showcase in the documentation of the final year project. Based on the research, I found out that online reviews can be considered as electronic word of mouth, e-worm, and is omnipresent and part of many customer purchase journey. Reviews are gathered, collected, and shown to consumers in an easy to digest manner in a variety of settings. Businesses such as Yelp, Facebook, Google, IMDb, and Rotten Tomatoes offer venues for people to post reviews which are collected and shown to other users. Food review platform, on the other hand, can follow customer opinions in a way that traditional word of mouth communication would not be able to. However, unlike traditional word of mouth, reviews are always open to everyone. According to studies, the tighter the connection between restaurants and consumers via evaluation, the larger the beneficial impacts on company overall. On the other hand, food reviews are different in different platforms. This has been a concerning problem for customers to select the right platform to obtain the food reviews. Besides that, online review sites are generally excellent place to gain new business and increase sales. Obtaining a large number of positive evaluation on a third-party website might even be a part of solid marketing plan. So now we move on to the project scope. Before we moving on to project scope, let's look at objective of this project. So the first objective of the project is to investigate the problems that food review application and restaurant industry are facing. And the second objective is to design and develop a food review application that aggregates reviews from various websites and applications using React Native. And the last one is to validate and verify the efficiency of using food review aggregated application using React Native. Next, we will look at project scope. There are three main scopes have taken place for this project. So the first one is the basic. So it aggregates review from various websites and applications. For example, like the system allows user to use this application to review or revise restaurant or food of their choice. The second one is intermediate, provide utility or value to the user. For example, like user have a privilege to add review and able to view food reviews that aggregates across all platform and websites. And the last one is the advanced one, locate nearby food according to the location. For example, the system shall able to detect user location and preference in food choices. So next, we moving on to research design table. So this is the overall research design table for this project. The first research question is, what is the current problem that our customers are facing? So the method I used for this research was study literature review and existing system. And the outcomes I expected is to gain an in-depth understanding of restaurant industry and technology that can boost the industry. The second one was, what are the main functions applied in this application? So the method I used was produce a prototype, and the outcome I expected was produce a prototype that is able to fulfill the criteria of the research objectives. That is to design and develop a food review aggregated application. So the last one was, how does an aggregated application will enhance and boost restaurant industry out there? So the method that I was using was produce a working prototype. So the outcome I expected was produce a working prototype that able to aggregate reviews from different websites and applications. So this is overall the research design table. So next we move on to literature review. So before I move on to app demonstration, so this is the last part of the presentation. So lastly, there are three main literature review was used in the research. Number one is online word of mouth, characteristic of Yelp.com reviews. So this literature review tells me about the characteristic of an application called Yelp and the use of food reviews in restaurant industry. The second one is text mining customer reviews for expect-based restaurant ratings. This particular literature review tells me about the ways that reviews could be extracted and displayed, and later on it helps for one of my methods that has been used to develop for this application that's called web scraping. And the last one is UI framework for React Native. So this literature review explained me about the pros and cons using React Native framework. So mostly the literature review that I go through aim to explore various concepts and techniques to create this food review aggregated application. And additionally, this literature review also discussed extensively about the challenges and existing web applications similar to food review application, also about analysis of customer online review and customer communication on online platform. So this is about my presentation. So now we move on to our app demonstration. I will explain more about my application. Thank you. Hello, welcome to my application demo. So this is my application. Sorry, this is my application. So I use Expo Development Client to run my emulator. So in React Native, you don't have to code twice to use in iOS or Android. For example, to run a iOS application, uh, you need to code in Swift or Objective C, and you want to run an Android application, you need to code in Java or Kotlin. But if you use React Native framework, you don't have to code in either way. You just have to code in JavaScript, HTML, and CSS. Actually, it's quite different if you compare to actual type of JavaScript. React Native is like they have their own language how to use it. So I studied for 4 months how to really use it React Native. So that's one of the advantage for React Native. You don't have to code two times. Just to code once, translate to their native code, Like for iOS, you just translate to Swift. For Android, you translate to Java. Yeah, you don't have to code twice. That's the main advantage of React Native. So that's why I use this popular framework to do my final year project. So let's stop wasting time going to the application. So to use this application, you need to log in. To log in, you need to have an email address and password. Let's say you don't have an email address and password. We enter a wrong email address and password wrong. It doesn't authorize me to enter because there's no user record been identified. So to have to enter to this system, you need to register as a user. Like you can see here, there has been 4 users been registered. Only this registered user can enter to the application. So let me show you how I register and enter into it. So first I write the name, then the email address and the password. So press sign up, then it goes to the main login page. Then as you can see, I refresh, new user ID has been created, kadir@gmail.com. So to log in, I just enter, let's say if I enter the right email but the wrong password, I still cannot enter. It shows me invalid password or the user does not have the same password. So what I do was I must do was I must enter the right password to enter. So yeah, there you go. So this will be the main page of this application. You can see it direct to the nearby restaurant in Kuala Lumpur. So it's like location based service. So I don't have to go there, type Kuala Lumpur or Selangor to find for the food. It automatically finds the nearby place in your area. Let's say now I'm living in Kuala Lumpur, it shows me the foods and restaurants in Kuala Lumpur. As far as now, I know, as far as I know now, I only added 4 restaurants to the system. 4 restaurants as the system. If you press, if you press it, you can see the details of this restaurant and the ratings across different platforms. So one is like aggregate ratings we get from different platforms. So it just analyze and shows the average rating. So it will be easier for the users to see. And if the user want to send message to the app, you just have to press this and you can type in the message and send it. I'm sorry, the system is quite slow. That's the main disadvantage of React Native. It's not as fast as the native framework like Xcode or Android Studio. That's one of the disadvantages of React Native. So if I want to go to the user profile, just have to press this. So you can see the followers, following, setting button, and everything, the recent activities and everything. So now I have to go back to see the reviews, aggregated reviews. Okay, before that, down here is also the same one, like the on top one, because all the same. I only enter like four restaurant details. So now we move on to the reviews. So if you want to see the reviews, usually have to go to the details page, then press reviews. Now you can see the reviews across different platforms. Right now, I only take reviews from two platforms, two websites. One is Facebook, and one more is TripAdvisor. Like can you see? So how I take the reviews is I use a web scraping tool. For example, web scraping. I use Python and a web scraping package called Beautiful Soup to extract the data and save it into my Firebase. So how it does was I go to this URL. So I find which paragraph. Let's say I want to have first the four latest reviews. Let's say 1, 2, 3, 4. So I state the which paragraph I want to go. Let's say paragraph P. So I wanted the first four reviews. So I state the number 0, 1, 2, 3. Then I save it and send to my file store. You can see in my file store there will be these reviews. Sorry, need some time. Forgot about this. So as you can see the reviews from this one is from TripAdvisor, and this one is from Facebook. You can see the reviews is here. So later on, I take this data, fetch this data, and display it on my application like this here. So it is one of the main tool I use for extracting my data from website. It's one of the main method I use to aggregate the reviews from different platform or website. So this is how I aggregate the reviews. You can see the user can see the reviews. So if the user want to enter their review, they have to go to review one. Review. They have to press whatever review. Let's say we have the food is good. We have to save the review. Then later on, my Firestore will get my Firestore will save the added review, and later on display. Let me refresh this page. It's very slow compared to the native framework. Let me refresh. Okay. Now you can. Oh, sorry. Now you can go to the bottom of this application. Okay, there you go. The food is good. This is the review is added by me. So this is one of the methods. This is one of the functions for the user. So that is about my application demo. Later on, if the user want to log out, they have to go to the main page. Then we have to press log out. That's it. That's it about my application. So I hope you understand what I try to present to you. So this is the codes that have been used. This is the key. Actually, we need this key to access the Firestore. So I got the key from the Firestore, then use it in my code. Later on, I have the access to access my Firestore. So that I have the access to access my Firestore for that particular reason. So this is the main app, my main app code. You can see these all the screens, and inside the screens they have codes, what they have the codes, their functions. So that's it about my application. Thank you.
Hello, this is my presentation for my final year project. So my final year project will be traffic sign recognition system. So we start off with the introduction. Traffic signs play a huge role in road safety, mainly because they indicate drivers about the situation of the road. The issue here is that most drivers, they don't tend to look at the traffic signs even though they were meant to guide us on the road. There are existing systems that helps indicating the drivers about the traffic signs on the road. However, the downsides of those systems is that they will sometimes fail to classify the traffic signs correctly due to their mediocre recognition rate. So recently, deep learning has become a hot topic in machine learning field, mainly because they achieve high accuracy in classification tasks, particularly in image classification. However, they are not very practical for real-time applications because they require heavy computational power to operate. So, the aim of this study is to build a traffic sign recognition system that is able to achieve high accuracy in traffic sign classification. At the same time, it requires low computational power to operate. There are three research objectives here. So the first one is to study the existing deep learning algorithms. The second one will be designing and develop the traffic sign system that uses less computational power than the current state-of-the-art traffic sign recognition systems. And the third one will be to validate the accuracy and the power required of the developed system. In the scope of study, there will be three levels. The first one, which is the basic. As for the functions, the system shall be able to read the traffic sign image as input during the model training. The second one will be the system shall be able to predict and classify traffic sign images regardless of the model accuracy. So the second one, which is the intermediate level, the functions will be the model of the system shall have lower trainable parameters than the state-of-the-art models. And then the system shall be able to deploy on a web server. The third level, which is advanced, the function will be the system shall be able to achieve high accuracy in traffic sign classification. The system shall be able to classify traffic signs at a low execution time, and the system shall be able to display the model interpretation. So this is the research design table. The first research question will be, will the existing system produce accurate results? So the method for this question is that we use literature review to list out the possible algorithms and functions used for those systems. The second question will be how to design a traffic sign recognition system that uses less computational power to recognize the traffic sign than current state-of-the-art systems. The method here that we use will be through analysis of the experimental results from existing systems. So this way, we will be able to use that analysis to produce a functional prototype of the system. The third question will be, will the developed system achieve high accuracy in traffic sign recognition tasks and maintaining at a low computational power? The method here will be through experiment, so that way we can evaluate the accuracy and the computational power of the system. So this is the summary of literature review. The first one will be convolutional neural networks. So this deep learning architecture can achieve very high accuracy in classification, and it excels particularly in the image classification task. The second one will be local interpretable model agnostics, which is short form as LIME. This algorithm helps analyzing the interpretation of the model after each image classification. It is very useful for deep learning models, such as the CNN just now, because they are very complex and hard to understand. The third one will be Python. So Python is an easy to learn programming language and offers a wide array of libraries for machine learning and image processing like TensorFlow, Keras, and Pillow, and etc. Next one will be Streamlit. So Streamlit is used to deploy the developed system to a web server for testing purposes. And last but not least, which is the Agile model. So Agile model is used as the software development life cycle because the scale of the project is very small and can easily be responded to changes. Okay, so here is my product demonstration. We'll start off with the image classification with GTSRB dataset. So you can see here is the image as the input image. We'll start off predicting the traffic sign. You can see here the predicted label here is 2 and it's 0.67 seconds. Here is the model interpretation using the line feature. And since it's labeled 2, we'll take a check with the label list. You can see here that the input image matches the label list image. We'll use another image as example. Okay, so we'll predict the traffic sign. So here the predicted label is 1 and then the execution time is 0.68. You can see here it matches with the model interpretation, and here we can see that the input image matches with the label list. So we use a different data set, which is Belgian TS. Okay, we'll predict the traffic sign. It's label 6, and here the class is the same. We'll take another example. Okay, so here we got 53 class, and then the predicted label is 53. So here we'll go on towards the dataset details. So here in TSRB, you can see that the total number of images is 39,000. And here is the number of classes separated in a graph. As you can see here, the dataset is quite imbalanced in terms of the number of images. And here is the graph visualization of the dataset in Belgium TS. Similar to the GTSRB, both datasets have very imbalanced data. So here in the model summary, we'll focus, it shows the network architecture, but we'll focus towards the end, which is the total parameters of the network architecture. Here you can see it has 94,000 parameters in GTSRB, whereas in Belgium TS there is over 100,000. There is a number of difference, mainly because of the number of classes. So here is the report of the GTS-RB. The model accuracy is around 98.03, and here is the model accuracy and the model loss. And here is the classification report of each of the classes. And here is the report for Belgium TS. It has a model accuracy of 96.86. And this is the graph of the accuracy and loss during the training and evaluation and validation. And here is the classification report of the number of classes. Here is the results. So you can see there are two models being compared. One, which is the benchmark test model, ENET V1. Another one will be the developed model. Note that both models are using the same GTS-RB dataset as benchmark. So the benchmark test model has an accuracy of 98.69, while the developed model has an accuracy of 98.03. The ENET V1, however, has a number of parameters of 900,000, while the developed model has a number of parameters of 94,000. As for conclusions, in comparison with the state of the art model just now as benchmark test, although the developed model is achieved slightly lower in the model accuracy, it is, however, that the size of the network architecture is 10 times smaller in terms of number of parameters. So for future enhancement, we will perform a system integration into a real-time environment. Another one will be increasing the model accuracy in classification. Thank you.
And that is the computing project showcase by our students. Thank you to all the students demonstrating their research today. Up next, tune in to the compilation of the works of our GPS1 game development students.